All right, today we're going to cover geometric sequences, and this is a topic that's really important for the end of course exam. So I thought we would start with one of the released questions from last year's exam, question 32, to see how this works. It's really not that hard. The number of bacteria on a microscope slide doubles every hour. What does that mean if something doubles every hour? What are you multiplying it by? 2, right? You're multiplying it by 2. If you're doubling it, if you start with, let's say you start with $5, and you double it, doesn't it turn into $10? And then 20, right? And so on. You're multiplying it by 2 every hour. There are initially 4 bacteria present. Create an explicit function f to model the growth after n hours. This sounds so hard, but it's so easy. We're starting with 4. We started with 4 bacteria. But you just told me that when we double something, we multiply it by 2. And then we multiply it by 2 again. And then we multiply it by 2 again, which sounds like it's an exponent. It's 2 to the n. And that's it. That's the correct answer. That is what they call the exemplar response, according to the end of course exam scoring people. And this thing right here is called the common ratio. It's the thing that is being raised to a power. It's what you're multiplying by over and over and over again. And this is what is called a geometric sequence, because we're multiplying it by the same number every time. Let's look at some examples, some more examples. So I've got here, write the formula for the geometric sequence. Let's look at this first one. We're starting with 256. So that means when I get ready to write my function, the number out in front is 256. That's what I'm starting with. Now, you've got a calculator. What am I doing to the number every time? What am I multiplying it by? I'm multiplying it by something every time. And remember, fractions are okay, decimals are okay. What am I multiplying it by every time? I'm not multiplying it by 2. Aren't I dividing it by 2? I'm dividing it by 2 every time, aren't I? Right? What's 256 divided by 2? It's 128. 128 divided by 2 is 64. 64 divided by 2 is 32. Well, dividing by 2 is the same thing as multiplying by 1/2. So my function is 256 times 1/2 to the x power. Now, if you're watching this at home, I'd like for you to pause the video and try to come up with our geometric series formula for number 2. All right, you've had a chance to work on this. Our first number is 5, so that's out in front. And if you've paid attention, each time we are multiplying by 3, times 3, times 3, times 3. So this is 5 times 3 to the x power. Now, one of the other nice things about a geometric sequence is there's a way for me to find a term that's way out there. I've just got, what if I wanted to know the 7th term? Well, what I'm going to show you would also work for the 27th term, or the 47th term, or the 50th term, all right? So once I know my function, all right, if I want to find the 7th term, I plug in 6. I plug in 1 less. And that is this formula right here that I've already got on your notes template. The nth term of a geometric sequence is the number out in front, the a, times the common ratio to the term I want minus 1. You just take away 1. So if I wanted to find the 7th term, I would plug in 6. If I wanted to find the 33rd term, I would plug in 32. All right? So on this problem, if I want to find the 7th term, I'm going to do f of 6. So that would be 5 times 3 to the 6th power. And let's take our calculator and find out what that is. I believe when you do this, don't we get 3,645, right? So the reason that we subtract the 1, everybody, the reason we subtract 1 is if you look up here at this sequence, the very first, this thing that we think is the first term is actually plugging in 0. Because what's x, anything to the 0 power is 1, right? So I would have 5 times 1, all right? And that would give me my 5, all right? So you're always subtracting 1, all right? This is the first term, all right? But to actually find it using this function, you would actually plug in 0, all right? Now, you're also going to have some problems like this next one. Find the next 3 terms in the sequence and write the formula. I do want to erase this, what I had in up above here. That could be, I don't want that to be confusing to anybody. So my first number is 3. And what am I multiplying it by each time? -4. So that our common ratio this time is -4. Make sure you put that in parentheses, -4 to the x. All right? So this says find the next 3 terms. So there's a couple ways you could do this. All right? This is the first term. This is the second term. This is the third term. This is the fourth term. If I wanted to find the 5th term, I would find f of 4. Remember that? We plug in 1 less. So you could use the formula. F of 4 would be 3 times -4 to the 4th power. And we're trying to find the 5th term, so it's going to be 3 times -4, make sure you put in parentheses, caret 4th power, and we get 768. So the next term up here is 768. Now, you could either use the formula, or you can just keep multiplying it by -4. Somebody take your calculator and do -4 times 768. -4 times 768 will give us the next term. What is it? Yeah, it's going to be -3,072. All right, and so you could just keep multiplying by -4 if you wanted. But I wanted to show you, you can do it using the formula. All right? One thing about your homework tonight that I've got written here. On all of your problems you do from the book tonight, I want this formula. Your book does not ask you to write out the formula. I want you to write out the formula because that's something the end of course exam asks you to do. So on every single problem, I want this formula written out. Okay? One last thing. What is an arithmetic sequence? Because your book asks some questions about, is this an arithmetic sequence or is it a geometric sequence? Well, with an arithmetic sequence, there's constant change. We're not multiplying by 3 every time. We are, if you look at this first one, we're adding 5 each time. Okay? That one is what we call an arithmetic sequence. All right? If you look at number 2, this one is also an arithmetic sequence. We are adding 2 every time. So that one is, these two are arithmetic sequences, but you're not going to have to deal with that very much in your assignment tonight because it's going to be 90% geometric sequences. That should get us started, and this will definitely prepare us better for the end of course exam.